Section 2.3 is solving multi-step equations. I can solve multi-step equations in one variable. Big ideas here. Equivalent equations are equations that have the same solution. The solution of a multi-step equation can be found using the properties of equality and inverse operations to form a series of simpler equations. And the properties of equality in real numbers can be used repeatedly to isolate the variable. Example 1, we're going to simplify this here. And we're going to do it by first combining like terms. So before we can solve, we need to make sure both expressions are as simple as we can get them. Keep in mind, an equation is just two expressions set equal to each other. So here my left expression is 5. My right expression is a little bit more complex. And if I look at this expression here, I can simplify it by combining the things that go together. 5m and 2m. And since they're in the same expression, on the same side, it's like they're on the same team. We add them up. So 5 plus 2 gives me 7m. And I bring down what's left. Now, 5 is as simple as we can get it, and so is 7m minus 23. Both sides are as simple as we can get them. And at this point, we can start solving. We check what's happening to our variable. Right now, it's being multiplied and subtracted. So if we work PEMDAS backwards, we're going to get rid of our subtraction first. I get rid of subtraction by adding. So I'm going to add 23 to both sides. It's our inverse operation. It's how we get to 0. Negative 23 plus 23 gives me 0. Now, m is being multiplied by 7. To get that to be 1, which is what we're looking for, we divide. Again, our inverse operation for multiplication is division. 7 divided by 7 gives me just 1. And whatever I do to one side, I have got to do to both in order to keep it equivalent. And 4. So 4 equals m is our solution. To check this, we plug it into every spot that we have a variable. So 5 equals 5 times 4 minus 23 plus 2 times 4. And check. 20 minus 23 plus 8, we multiply first. I get negative 3 plus 8, which gives me 5, which does equal 5 here. So we are correct. Now feel free to pause here and give this a try if you'd like. Again, we need to simplify both of our expressions. So my left expression here has 3 terms. 2 of them can be combined. I can take 11m minus 6m. And again, these are one expression. Since they're an expression and on the same side, we add them up just how they're written. So 11 minus 6 gives me 5m. And I still have this minus 8. 22 is as simple as we can get it. From here we look. My m is being multiplied by 5 and subtracted by 8. We get rid of any adding or subtracting first. Anything that's not attached to our variable or not grouped with our variable. Negative 8 plus 8 is 0. Double check that to make sure that's true. We get 30. Now m is being multiplied by 5. I get rid of multiplication by dividing. It's its inverse operation. It undoes itself. And here I get 6. And if we plug it back in, I get 66 minus 8 minus 36, which does give me 22. So plugging it back in to check does work. Same idea here on B. Again, we need to simplify both expressions. 14 is as simple as we can get it. But on the left side here, I have negative 2y plus 5y. Negative 2 plus 5 is 3y. We do not change it unless we cross over the equal sign. If we take it to the opposite side, we do the opposite operation. But for now, if they're on the same side, we add them up just how they are. Now to get y by itself, 2 things are happening. It's being multiplied and it's being added. We get rid of our addition first by subtracting. That's how we get it to 0. 5 minus 5 is 0. 14 minus 5 is 9. We have multiplication, which we get rid of by dividing. And whatever I do to one side, I've got to do to both. So y equals 3. And again, we can plug that in to check, and it will check there. In example 2, Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If her total is $67, we want to know what is the cost of one shirt. So here we're going to take, it says total is 67. Total means we're going to add up all the costs, since we're talking about cost of a shirt and we're talking about money. So all the costs. Well, to find cost, we take quantity times price. All the things that were bought were one t-shirt, and 4 times the number of bumper stickers, and 2 more shirts. So 2 times the cost of the shirts. This is cost of t-shirts and cost for bumper stickers. And then no bumper stickers. The total again means we add up all of our costs and set it equal to 67. We also know a little bit more here. We know that bumper stickers cost $1 each. So B is going to be 1. Instead of a B, I'm going to put a 1. So I have 1 t-shirt plus 4 times 1 is $4 spent on bumper stickers, plus 2 more t-shirts gives me $67. Right now we have all the money she spent and all the things she spent it on, or how she spent it. We're going to combine our like terms here. Remember, we still have 2 expressions. So 1 t-shirt plus 2 t-shirts gives me 3 total t-shirts were bought and $4 was spent on bumper stickers. Now, to get t by itself, I subtract the $4 that were spent on bumper stickers because that gives me 0. And all I have left is 3 t-shirts equals $63. T is being multiplied. We get rid of it by dividing. And the cost per t-shirt was $21. We can double check. 1 t-shirt plus 4 $1 bumper stickers plus 2 t-shirts will give us $67. Feel free to pause here and give this a try if you'd like. Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16. Their total cost is $72. How much is 1 pack of strings? So they're shopping here. Their total cost, which means we're going to add up all the costs and have it equal 72. Is means equal. The things that they spent their money on were 2 packs of strings. I'm going to use P for packs of strings because S's are hard. I always think they're 5s. Kate bought 2 packs of strings. And Kate bought a book. And it was just 1 book there. Now, we also know that the book costs $16, so I can plug that 16 in for B, because remember, these are our prices. These are our costs. We're adding up our costs. So we take price here with our variables times quantity to get cost. So 1 times 16 is going to give me just $16 spent on books there. We can also add up how many total packs of strings. If Kate had 2 and Noah had 2, there were 4 total packs of strings. Now that our left side and right side are as simple as we can get them, we can solve. First thing I'm going to do is get rid of my addition by subtracting. That gets me to 0. When I subtract here, I get 56. Then I can divide to get rid of my multiplication. Remember, we go in reverse PEMDAS, and it's $14 per pack of strings. Reverse PEMDAS. So we look here. Do we have any subtraction? No. Any addition? Yes. We get rid of our addition. No division, and then multiplication. So we go in reverse PEMDAS order to solve those equations. Here, we're still going to simplify our left side and simplify our right side, both expressions that are set equal to each other. And on the left side, we have parentheses. Remember, things aren't simplified until all the parentheses are gone, all like terms have been combined, and any fractions have been reduced. So to get rid of my parentheses here, because I can't take 2x minus 1, what I can do is I can distribute. And I can take negative 8 times 2x, and I can take negative 8, keep the sign with our 1, minus 1. Multiply negative 16x, negative times a negative gives me a positive 8. And now I'm as simple as I can get on the left side. On the right side, I just have 36. So left side and right side are both as simple as I can get them. At this point, I can go ahead and solve for my x. We do reverse PEMDAS, or get rid of any adding or subtracting first. Then divide by negative 16 to get rid of any multiplication. And again, we take that sign with the number. It's a negative 16, so we divide by negative 16. And then reduce here if we can. I can take a 2 out of both of them. Don't forget that negative. I can take a 2 out of both of them again. So I get negative 7 over 4. Or negative 1.75. And if we check that here, it will work. Now, same idea here. Before we can solve equations, we have to have them completely simplified. Right now, my left side is as simple as I can get it, but my right side is not. I need to get rid of those parentheses, and I do that by distributing. Right now, my 3 is being multiplied times my difference. So I'm going to take that 3 times both terms inside. Again, we keep the sign with the number, and I'm going to come up with a difference without the parentheses. So I took 3 times 2x to get 6x, and 3 times negative 6 to get negative 18. Now, I've got two things happening to my x. It's being subtracted and multiplied. We get rid of subtraction by adding, and we do that step first. Whatever I do to one side, I've got to do to both. Double check to make sure that's 0. Negative 18 plus 18 is 0. So on the right side, all I have left is 6x. On the left, I have 36. Now, my x is being multiplied by 6. I get rid of multiplication by dividing. And I get 6 equals x, or x equals 6. If we plug it back in, it does check. 12 minus 6 is 6 times 3 gives me 18. So we know we're right there.